All right, everyone, let's jump right in. Today, we're going to talk about a really fundamental concept in algorithms called the greedy method. Now, the name sounds a little, well, selfish, but trust me, by the end of this, you'll see it's actually one of the most intuitive and powerful tools you have for solving some seriously complex problems.
So to really get what this is all about, let's forget about code for a second. Just picture this. You overslept, your cab is literally 5 minutes away, you've got one small bag for a whole weekend. What's the very first thing you're going to grab?
You're not going to start folding your socks, right? No way! You're going to scan the room and instantly grab the things that give you the most bang for your buck space-wise. You know, your laptop, your charger, your wallet, whatever is most valuable to you in that moment. You're making snap decisions based on what seems best right now.
Well, guess what? If that's what you just did in your head, then congratulations. You've already mastered the basic idea behind the greedy method. Seriously, you just made the best possible choice at each immediate step, hoping that all those small, good choices add up to a perfectly packed bag.
Okay, so let's take that gut feeling, that common sense packing strategy, and give it a proper name and structure. We're going to see how that intuition turns into a real, honest-to-goodness algorithm.
So, here's the textbook definition. At its heart, the greedy method is all about making the locally optimal choice. All that means is you make the choice that looks best at this very second, without worrying about what might happen 10 steps down the road. The big idea, or the big hope, is that if you keep making the best short-term decision over and over, you'll end up with the best overall solution, or the global optimum.
And the process itself? It's beautifully simple. You can really boil it all down to these three things. Number 1, look at your options and pick the best one right now. 2, lock it in. Add it to your final solution. And 3, just repeat. Do it again with what's left until there's nothing left to do.
Okay, let's put this into practice with a formal problem. And I mean a classic one. You are absolutely 100% going to see this in your coursework and on your exams. It's basically the final boss version of our packing scenario, the knapsack problem.
So here's the setup. We've got 3 items. Each one has a profit, how much it's worth to us, and a weight. Our knapsack, or our bag, can only hold a total weight of 20. The mission, should you choose to accept it, is to fill this bag to get the maximum possible profit.
So, I'm asking you, look at this table. What's the greedy move here? What does best at the moment even mean in this context? Do we just grab object 3 because it has the highest profit of 25? Or maybe object 2, since it's the lightest? This is the central question we have to answer.
And here's the secret sauce for this particular problem. For what's called the fractional knapsack problem, the smartest, greediest choice isn't just the highest profit or the lowest weight. It's the best value for its size. We need to find the item that gives us the most profit for every single unit of weight it takes up.
Okay, let's run the numbers. For object 1, we just do profit divided by weight. So 24 over 15, that's 1.6. For object 2, it's 15 over 10, nice and easy, that's 1.5. And for object 3, we've got 25 over 18, which comes out to about 1.38. So once we calculate our greedy metric, our new value score, it's clear. Object 1 gives us the best bang for our buck. It's our first pick.
All right, let's follow the rule. Step 1, we take all of object 1 because it has the highest ratio. It weighs 15. Our knapsack started with a capacity of 20, so after we put this in, we've got 20 minus 15. That leaves us with 5 units of space left. Simple enough. On to step 2. We look back at our sorted list. The next best item is object 2, with that ratio of 1.5. But hang on a minute. The whole object weighs 10, and we've only got 5 units of space left. It's not going to fit. So what do we do? And this right here is what makes this the fractional knapsack problem. For this version of the problem, you are allowed to break stuff up. So since we have 5 units of space and the object's total weight is 10, we can take a fraction of 5 over 10, which means we take exactly half, or 0.5, of object 2.
So let's add it all up and see what we made. We get the full 24 profit from object 1. Then we get half of the profit from object 2. Its full profit was 15, so half of that is 7.5. Our grand total is 24 plus 7.5, which equals 31.5. And here's the important part. For the fractional knapsack problem, this greedy strategy is guaranteed to give you the best possible answer every single time.
Okay, so this whole greedy idea isn't just about packing bags. Let's look at another classic problem where this shines, something called job sequencing with deadlines.
The setup is pretty straightforward. You've got a list of jobs, and each one gives you a certain profit, but it has to be done by a specific deadline. The greedy choice here? Just go for the money. You sort all the jobs by profit, highest to lowest. Then you try to schedule them, starting with the most profitable one, in the latest possible time slot that still works for its deadline. That way, you keep the earlier slots free for other jobs.
All right, let's switch gears. Let's talk about what really matters for your exams. This is the stuff you absolutely need to have locked in your brain about the greedy method.
Okay, this is critical. Think of the greedy method like a sprinter. It's super fast and simple because it only cares about what's right in front of it. But, and this is a huge point for your exams, it does not work for every problem. Remember how I kept saying fractional knapsack? That's because if you have to take the whole item or nothing, the 0-1 knapsack problem, this exact same greedy strategy can actually fail. It doesn't always find the best overall solution.
So this slide is basically your study guide. Commit these to memory. If you see these problems on an exam, your brain should immediately start thinking greedy method. We've already covered the first two, but you should also note that famous algorithms you'll study like Prim's, Kruskal's, and Dijkstra's, they are all fundamentally greedy at their core.
So when you see a quote like this, what does it really mean? It's just a more formal way of saying what we've been talking about this whole time. The greedy method's power comes from its ability to take a massive, complicated problem and chop it down into a series of small, manageable, what's best for me right now decisions.
So, if you only remember one thing from today, let it be this. The greedy method is all about this simple mantra. Choose what looks best now, and then repeat. It's simple, it's fast, and when you use it on the right kind of problem, it's incredibly effective.
And that really leads us to the final, most important question to think about. We saw it works perfectly for the fractional knapsack, but is making the best short-term choice always the right long-term strategy? Thinking about that question, about when this simple approach isn't enough, well, that's the perfect setup for our next topic, dynamic programming. But we'll save that for next time.